Right, welcome to this video on the sine rule. And what we've done up to now, we've looked at right angle triangles. And here we clearly don't have a right angle triangle. We have A, B and C. And what we notice is that the length of this side is obviously going to depend on how big this angle is between these two sides. So if we move this side round, this AB side, without changing the length, then what we notice is that as the angle gets bigger, the length gets bigger, and similarly if we do the same with C, and if it gets smaller, the angle gets smaller, the side gets smaller. Now moving on to a triangle where we can move anything around, what I've done is I prepared these fractions. So we're going to, and it's very key that we label our triangle correctly. So we have a triangle, we always label it capital A, capital B, capital C to give my angles. And then the opposite side to A, I'm going to label little a. And the opposite side to B, I'm going to label little b. And the opposite side to C, I'm going to label little c. And it's really important you label these, because obviously this side depends on the size of this angle. And this side depends on the size of this angle, and so on. And then if we work out these ratios, A over sine A, we can see that 10 over sine 57 is 12. And if we do B, here, 11.5 over sine of 74, we see that's 12, and similarly for C. And if we move them round, we can see the computer recalculating the values of the ratios. And what you notice, it doesn't matter what size of angles and what length of sides I have in this triangle, the ratio of A divided by sine A is always the same for all three. Okay, it's always the same. So we have this thing called the sine rule, where A over sine A equals B over sine C equals C over sine C. Sorry, I said B over sine B, C over sine C. And similarly, we can turn these all upside down and they'll still be equal. So sine A over A will still equal sine B over B and still equal sine C over C. And we use this version with the little letters on the top, the sides on the top, when we want to work out sides, because it makes the algebra easier. And we use this version when we've got the angles on the top to work out angles, because again, it makes the algebra easier. Right, so let's look at some examples. So we've got our formula here and we've got our triangle here, and we're going to try and work out these questions. So moving on to our first question, we're going to find the side x in each question, giving your answer correct to one decimal place. So we're going to do this one first. So I'm going to label my triangle A, B, C, and my opposite side A, my opposite side here B, and my opposite side C. So we can see we've got the B's and we've got the A's. So we can use that A over sine A will equal B over sine B. So put our numbers in. Well, we don't know little a, it's x. We do know sine of 30. And we know that equals B over sine B, so that's 2.5 over sine of B, which is sine of 80. So to find x, we've got to times all of this by the sine of 30. So we get x equals 2.5 over the sine of 80 times by the sine of 30. So we get our calculator and we do 2.5 divide by sine 80, close my brackets, times by sine 30, close brackets, and I get 1.26. Now to one decimal place, that's going to be equal to 1.3 centimeters. Okay, moving on to this one, label our diagram. So we have got to find x. Now we're going to call this side capital A, this side little a. I like to use A for my values where I don't know them. I'm going to call this one B, this one C, call this one little b, call this one little c. And you can see I've got little c and I've got capital C. But what we need is an opposite pair. But we also need when the unknown is A, we need to find this angle. Well, we can find this angle because we know the angles in a triangle add up to 180 degrees. So if we do 78 plus 69, so add on 9 to 78, we get 87. Add on 60, we get 147. Sorry, 147 for these two angles. Take that away from 180, and we get 33 for this angle here for A. So we're going to use, always write out the formula so it helps you learn it. We're going to use sine A over sine A equals C over sine C. Okay, and we're going to put that in. So we've got X, we've got sine of 33 equals 7.1 over the sine of 78. So therefore X will equal 7.1 over the sine of 78, and we're going to times by the sine of 33 to get X on its own. We grab our calculator, so we do 7.1 times by, or divide by we'll do first. It doesn't really matter the order between times and divide. So we're going to divide by sine of 78. And then we're going to times by the sine of 33. Equals. And we get 3.9, what was it? 3.953. So we're going to round this up because the second decimal place is a 5, and that's going to give me a 9 added on 1, so we're going to get 4.0 centimeters to 1 dp. Right, moving on. What we're going to do is we're going to find the angle in these questions. So here's our angle A, and we're going to make that little a, and here's our angle B, and we're going to make that little b. We can label C and little c. So we're going to change the way we write our formula now. We're going to write sine A over little a because we want to find the angle. So we put the angle on the top. And we're going to put sine B over little b. Sine A, so we don't know A, we know that it's x. So we've got sine of x over 5.3 equals the sine of B, which is sine of 41. Over 4.6. So just moving that up. So we can see the sine of x will equal sine of 41 over 4.6 times 5.3. Put that into our calculator. So we're going to do sine 41 divided by 4.6 times by 5.3 equals, and that gives us our sine of x. So sine of x is roughly equal to 0.7559. To 4 decimal places, 0.755. We can put an A to put dots. Okay, to indicate there's more. Now, to find the x, we need to do inverse sine. So we press the shift button, press the inverse sine, and then we put the answer that we just got in, and it will give us our value of x. So x equals 49.1 degrees. So we can write 49.1 in here. Let's do this one. So we have got x here. But we don't have this side here, which is going to make things a little bit trickier. We do have, let's just make this one, it doesn't really matter what we label them. We've got A, we've got little a, we've got C, and we got little c equal to here. So what we can do is we can actually find this angle here first, the C one. And once we found this, we've got this angle and we got this angle, we can then find that angle. Okay, because the angles in the triangle add up to 180. So what we're going to do, we're going to use the fact that sine A over little a will equal sine C over little c. Put the values in. So sine A is sine of 84 over little a, 6.4, equals sine of C, we don't know that, over little c, which is 5.1. So sine of big C will equal sine 84 over 6.4, and I've got to times by 5.1. Let's put that into our calculator. Clear all of that. So we have the sine of 84 divided by 6.4 times by 5.1 equals, so that equals 0.7925. 0.7925 and so on. So C will equal, let's do shift sine answer, 52.4. Now we know that A is going to be 84 degrees. So we can add those up. So we're going to get a 0.4, we're going to get a 6, and we're going to get a 13 here. So 136.4. So our value of x will be equal to that taken away from 180, which is going to be 43.6 degrees. Moving on. We're going to look at obtuse angles and the ambiguous case. Now the problem is, because of the shape of the sine curve, so this is y equals sine x, and this is 90 degrees, and this is 180 degrees, and this is 0. So what you can see is there is a value between 0 and 90 where the sine of x is the same as a value between 90 and 180. So you could have an angle between 90 and 180 will have the same sine angle between 0 and 90. And what you can see is this is a symmetrical curve. So this distance is the same as this distance in theory. Okay, if I draw a nice shape of the curve. So we can, when we got an acute angle answer, because that's what our calculator will give us, and we can quite clearly, we've got an obtuse angle as the question. If we take our acute answer away from 180, we get our obtuse angle. So let's do that with this one here. So we've got A, B, C. So we're going to call this one little c, call this one little b. No, not little b, sorry. It's the opposite angle. I'm going to call it little a. And this one's opposite b, so we're going to call that little b. So we want to find c. So we've got sine c over little c equals sine a over little a. And then we can do, put that in. So we don't know sine c, so put that in. And we do know little c is 9.5. And we do know that a is 32. And we do know that little a is 5.8. So therefore sine c will equal sine of 32 over 5.8 times by 9.5. That gives us, get our calculator, we're going to have sine divide by 5.8 times by 9.5. Divide by 5.8 times by 9.5, and we get 0.867. Okay, so that gives us our sine of the value. So if we do shift sine, our answer, and we get 60.2 degrees. So we get C equals 60.2 degrees. But it's quite clear from our diagram that this angle is bigger than 90. So what value will that be? Well, actually C is greater than 90 degrees. Therefore, C will equal 180 minus 60.2. We just take our value away from 180 to find the obtuse angle, and that gives us 119.8 degrees for obtuse angle. And essentially, we have now covered all the things you need to know to be able to do the sine rule. And I think we'll stop the video there, because we have covered how to find sides, how to find angles, and also how to find the case where we have an obtuse angle when our calculator only gives us the acute angle answer.